So this is Module 10. We're building on time value of money concepts, but here we're going to look at capital budgeting. Capital budgeting is really a way to examine the profitability of multi-year investments. So looking at investments that are going to give you different types of returns over a period of time. And this corresponds to Chapter 10 in your textbook. So there's different methods of examining these decision tools. One is a payback period, a net present value, the internal rate of return, a modified internal rate of return, and then we're also going to go over an example building a spreadsheet. So capital budgeting evaluates investments that are over more than 1 year. We compare the investment requirements, the money that it takes to get started in the investment, with the expected returns in all the future years. For all these methods, you're going to need to determine the expected net cash flows in each year. Payback period. The advantages are that it's really simple. It's back of the envelope type decision making. It's easy to understand and interpret. The disadvantages are that it doesn't include any of the effects of the time value of money, and it doesn't include the value of future returns after the payback period, and so it doesn't measure total profitability, rather the speed of the recovery of the initial investment. So it's how many years does it take to recoup the initial outlay of funds. If it's not expressed in partial years, so if you have any part of a year's cash flow that's needed, you have to account the entire year. So an example, you have an investment with an initial cost of $10,000 and future expected returns of $2,000, $4,000, $5,000, $6,000, and $8,000 in years 1 through 5. What is the expected payback? How many years is it going to take in order to get your original $10,000 back? The answer is 3 years. By the end of the year 3, you will have recouped $11,000, which is more than the original $10,000. So you have your original $10,000. At the end of the first year, you get $2,000 back, but doesn't add up to $10,000. The second year, you get another $4,000, so you've received $6,000 back, but that's $4,000 short. Then in year 5, you get $5,000, which more than covers the rest of your initial investment. The net present value is the value in today's dollars of the return on the investment over the cost of the original investment. And this is also, anything that's positive means the project's giving you that expected return, the desired return. And so the desired return is the discount rate, and it's the rate desired that you make on the investment. So if you want to make 10% on the investment, that's your discount rate. An example, so in year 0, you have an investment that costs $20,000. In year 1, you get $2,000, year 2, $4,000, year 3, $6,000, year 4, $8,000, and year 5, $10,000, with a discount rate of 8%. So in Excel, you would use a function called NPV. So you do equals NPV, open parenthesis, your rate of 8% or 0.08, comma, and then you'd select the range, the values 0 through 5. So you'd highlight all of these cells. Close your parentheses. However, one thing to notice in Excel is that this first amount in the range is years 1 to the end. So it would only be the 2,000 to the 10,000. Then you've got to close your parenthesis and then say plus and click on the value in year 0, or this minus $20,000. The minus $20,000 is already in today's value, so it doesn't need to be discounted. But this MPV function is going to discount these amounts back to their value in today's dollars. Then it's going to add everything together. You can also do this on a calculator. When you do it, the answer would be $2,730.27. Since this is more than 0, this is a good investment, and it makes more than the 8% return. Another way we can look at it is the internal rate of return. It calculates the expected return on the investment as a percentage. If the IRR is greater than the discount rate, the desired return, it's a good investment. So here's our same example as we had before. Our Excel function that we can use is equals IRR, open parenthesis, and then the value, the range, year 0 through year 5. Close parenthesis, or you can calculate on your calculator. When you do that, you get an IRR of 12%. Since 12% is more than the desired rate of 8%, this would be a good investment. Both NPV and IRR give you the same decision. Both said that they were a good decision because, or a good investment because you were earning more than the discount rate. They express the results in different terms. IRR is easier for people to understand because it's a percent. Oh, you're making 12% on the investment. They immediately grasp that. With the NPV, when they say, well, your NPV is this amount of money, it's hard for people to grasp what that means unless they are, they have to be, sometimes have to explain what that means. The IRR will be understated if it's below the discount rate and overstated if it's above the discount rate. And the farther it is away from the discount rate, the more understated or overstated it'll be. If it's fairly close, it's not that big of a deal. And this is because it assumes that all your money is reinvested at the internal rate of return until the end of the project. So if you have something like an IRR of 60%, it's assuming that you can reinvest all that money until the end of the project and earn elsewhere and earn 60%, which is unrealistic, and that's why it's overstated. It can also potentially have multiple answers. If you have annual net cash flows that have positive signs, so positive returns, and then in another year you have a negative return, then that can cause it to have more than one answer. If you're good at your algebra and calculus, is what this means is you've got a nonlinear curve, and so you've got multiple optima. To fix the modified internal rate of return, or to fix it, we do the modified internal rate of return, or MIRR, and this assumes that the money is reinvested at the cost of capital until the end of the investment. We will only calculate the MIRR on Excel and not on our calculators. So in Excel, the MIRR would be equals MIRR, open parenthesis, values, year 0 to the end, so our minus 20,000 to our 10,000, comma, our finance rate, which is 10% for our discount, our finance rate, and then our reinvestment rate. The reinvestment rate is your discount rate, which is 10%. The finance rate is if you have to borrow money because you have negative cash flows in some of these years, then what rate do you borrow that money at? A lot of times I'll use the discount rate for both of these. As long as you don't have negative amounts in these years, that finance rate's not going to change. Whatever you put in for the finance rate will not change your answer in this case. But if you do have negative cash flows, then it will, and you'll want to think about it. And it shouldn't be this plus your 0 value. That should be off there. So the finance rate is used if you have negative years other than 0, and assume the reinvestment rate is the discount rate. Our answer is the MIRR would be 10.8% if 8% is used for the reinvestment rate. And I've just messed us up all over the place. 10.8% and 8% is correct. I don't know why I had 10% here instead of 8%. You can also see results for this and many others reinvestment rates on page 288 in your textbook. So putting it into practice, a large part of capital budgeting is really finding out what those annual net cash flows are. And so there's an example in the textbook beginning on page 294, and we're going to now show you how to set up a spreadsheet to use that example, and then your homework assignment is going to use that spreadsheet. One of the differences is that for what the example in the book assumes slightly different depreciation rates than normally would be found in IRS tables, and so I'm going to show you how to do it assuming those depreciation rates. But you can find IRS ones on in your book on page 85, and those are the ones that you'll have to use for the example. So let's start it here. So this is the template that you'll have for chapter 10. And green places are numbers to put that you have to put in. Yellow are your the final answers, and then down here is where it's going to calculate all of your net cash flows for the year. So I'm going to increase this just a hair so you can see it a little bit better. So we start off, we need to have the initial investment. What's it going to cost to get this new enterprise up and going? The example in the book says it's for a new hog enterprise, and it's going to cost $140,000 to get it set up. Terminal value is what you would have at the end of the project. In this case, after 10 years, we can sell all the equipment and stuff that we have for $21,000. growth, we have two things, our receipts or our sales, and also growth on expenses. So after the first year, how fast are those going to grow? And the book example is that those will be 2% each. The tax rate is 20%. The percent financed is, we're assuming that it's going to be 80%. That's a little unrealistic in today's dollars, or in today's world, because 80%'s more than most banks will lend you for a new enterprise. It'll probably be more down like 50-60%. The finance rate is 12%, which is also high for today's world. And then the discount rate is 19%, and the years financed is 10. The units per year, there's 240 sows, and each sow is going to get $720 of returns and $624 of costs. We can calculate our payment, so it's equals PMT is the function. The rate, which is the finance rate, right here, the 12%, comma, and now we need the number of periods. The number of periods is the years financed, comma. The present value is how much we're borrowing. It's the initial investment multiplied by the percent financed. And we don't have a future value, so we can do our closing parentheses and hit enter. This brings it up as a negative number because it's a payment. We put in a positive present value, so it returns a negative payment. If you want, but we want it to display as a positive number because we know that it's a payment, so I simply put a minus sign in there in front of it, and then it'll display as a positive number. I've given you some of the common Excel functions that you would use just right here, so you'll see the formulas. But when you start typing in the equals in the first letters and the opening parenthesis, it'll actually prompt you for all of those others as it did for the payment. So another thing that we need to do is we can depreciate these assets, and so there's $90,000 of buildings, $38,000 of equipment, and $12,000 of livestock. So we've got all the information that we need to create the net cash flows for each year. And so these numbers in green can also be thought of as our assumptions. So in year 0, you're going to have a down payment, and that's the only thing that happens. So we assume that in the first year before the project starts, you basically buy everything to get it started. Your down payment is simply going to be the initial investment multiplied by 1 minus the percent financed. So it's $28,000 that you're going to put down. In year 1, our receipts are going to equal the units that we have multiplied by the return per unit. For the next year, it's going to be the return for the previous year multiplied by 1 plus our growth rate on receipts up here. So by doing that, this number is going to grow by 2%. And I want to be able to copy it across. So if I do the F4 to get the dollar signs around my B9, then it'll always refer to B9. And so then I can just merely get my little skinny plus sign and drag it across. In the final year, in year 10, you're going to have the terminal value. So it's just plus or equals the terminal value. And then my inflows are going to equal my receipts plus my terminal value, and I can copy that all the way across also.